right, thanks, Bill. So, really the biggest thing with fiber, obviously, is as a fiber manufacturer, we believe that it's the future and now. The biggest dilemma that we face, that most customers are facing right now, is the fact that they're scared of it. It's hard to terminate. They feel like it's very complicated. So today I want to just kind of, demystify some of that. Try to keep things simple. We're not going to get super technical. At the end, if there are some questions or even after, please feel free to contact me. And we can answer anything that's more technical than this, but this will give you kind of a 10,000-foot view of fiber optics and sort of why and where to use them. To start, let's talk about there's two types of fiber that everybody's going to hear about. There's single mode fiber and there's multi-mode fiber. And I like to keep things very simple, so I kind of justify it this way. Single mode fiber is a smaller diameter piece of glass that light travels through. Single mode is what they usually consider long haul fiber. So things that are connecting Chicago to New York or New York to London are typically done on single mode. Has an infinite bandwidth, and distance is really never a restriction. Multi-mode has traditionally been known as the inside premise. So under 1,000 feet is kind of a generic number to use, but inside residence or commercial buildings is going to be more multi-mode. And there's different versions of multi-mode that we'll go to here just to kind of give an idea. For those that have been around a while like myself, we used to, back even in the late 80s, early 90s, we were pulling fiber in a lot of bundles, and that fiber was what they considered OM1. The electronics that they used were LED-based, where everything now is laser-based. So they had some very small bandwidth and distance restrictions. OM1 is not made really much anymore. There's some legacy equipment that people use it for, but you're not going to find it out there much. So where people start to kind of get confused is they see multi-mode, and there's OM2, OM3, and OM4. And it's a manufacturing process that creates the three. You can't create OM3 without creating OM4. And the real easy way to kind of think of it is like a camera lens that you can focus in and out. When the glass is actually produced, the clarity or the focus of the glass core itself changes over time during the manufacturing process. And so therefore you end up with yields of these different focused points on the glass. OM2, 3, and 4 all have the capacity to carry the same signals. They basically don't have the capacity to carry them the same distance. And what everybody should be able to see on the chart is OM2 can do a 10 gig network up to 82 meters. 10 gig is where they base everything as far as data transmission. It's not the capacity of the actual fiber. It's just sort of the standard that they've laid on right now to do things. So OM3 will do 10 gig up to 300 meters, or basically 1,000 feet. OM3 is the sort of standard in the industry right now. It gives you the ability to cover pretty much anything inside a residence or even a decent-sized commercial application. OM4 obviously can go a little bit longer. And as you can see, OM3 and 4 both have capacity to do 40 gig and even 100 gig networks. So to kind of keep things simple, OM3 is really where we believe everybody, should kind of be. OM2 is a little less expensive, so if price is a concern, you can see where you can kind of do things, get away with things at a little lower cost right now. Once we kind of get past the fiber itself, the big thing that people hear about are all the different ways that you can put connectors on. Mechanical connectors is what we're going to focus on today. This is what we believe is an easy to learn and a very efficient way of putting connectors on. But just to kind of make everybody understand, there are different connectors out there. As you can see, hot melt, anaerobic, epoxy polish. These are different types of connectors, and I'll go through the very basics of them. But in a mechanical connector, what's happening is there's a pre-polished piece of glass in the end of the connector, and basically we're making a splice, just like you would with a coax or an RCA or something where you might put a barrel in between. And what we're trying to do is make as good a splice as possible. In a hot melt or anaerobic and epoxy polish connectors, there is no pre-done piece in the connector, so you're sticking the glass all the way through a connector and polishing and adhering it to the connector in a fashion that some believe is a better termination. It's an older technology, but for some of those that may have done it or have been doing it, once you've gotten used to it, it's just like everything else. Fusion splicing. This is one that most people have heard of. Fusion splicing is taking two pieces of glass and taking an electrical charge and arcing them back together to basically give you the best connection of putting two pieces of glass together. Fusion splicing requires a very expensive machine. Traditionally, they run $10,000 to $30,000. In the AV world, it's just not a real big necessity. It's more of a data networking type of application where these get used. But to just kind of know that these are the different ways of doing them. Cable constructions. This is another area that people really try to overcomplicate and get things, so I felt that this is the best way to kind of show things. Simplex is very easy. It's a single fiber in a jacket. Traditionally, it's a 2 millimeter, 3 millimeter jacket with one strand of fiber in it. Duplex is two fibers, more of like a zip cable, so pretty simple. Distribution cable is typically going to be 2 to 144 strands of fiber inside of it. Most of the way fiber has been built when it gets to be multi-strand fiber is going to be traditional distribution style. The downfall is that the cable itself gets pretty big because you have each strand of fiber has its own little jacket in it, and then of course an overall jacket. So as you get more and more strands of fiber, the jacket just gets larger. Part of that jacketing is there to protect the fiber, and when I say fiber, the actual glass itself. And traditional fiber has some very sensitive mechanics to it that you don't want to build or break. You don't want to bend too many things, so they put a bunch of extra jacketing on. Micro distribution cables, same type of construction as far as strands of fiber, but with a lot less jacketing. So these are traditionally a lot smaller cables. And then breakout cables are, again, a buildup of a cable inside an overall jacket. Nothing real crazy. They become very big and heavy, and usually don't get to be more than 12 strands. And these are typically more like a bunch of simplex cables with an overall jacket bundled up. The three types of connectors that you're going to run into or typically are going to be, there's probably a dozen types of connectors out on the marketplace as far as styles, but these are the three most predominant in the audio, video, and networking industry. SC is what I call square connector. It's a little bigger, easier to handle, and easier to terminate. LC is a smaller footprint, more of a built for higher density, so you can get about twice as many connectors in the same amount of space as you can in SC. And then an ST connector is, I refer to it as kind of the B and C style. It's rarely used in the audio video industry, especially residential and smaller commercial stuff. It's really more government oriented, but at some point or another, most people tend to run by them. Cleerline is a company, we support SC and LC as far as manufacturing wise. ST we do not build, so just to be aware of that. Then we come to, well, what does it take to terminate? What are the tools required? You do need fairly specialized tools. You need a fiber optic cleaver, and the cleaver is basically like a diamond cutter or a hard tile surface cutter. You can't cut the glass. If you do, you basically will crush the end of it. So a cleaver is a wheel that goes back and forth and nicks the glass to try to break it off at a 90-degree end face so that you can put it into the connector. VFL is a light indicator. You can put it on the connector, shine it down the cable, and see if you have any breaks or bends anywhere that are producing the light. Helps make putting a connector on a lot simpler, which you'll see here in a few minutes. You need fiber strippers to obviously get the jacket off, and Kevlar shears. The Kevlar shears are a very important feature. Don't use traditional dikes or nips or anything that you're cutting typical cable with, because you'll just dull them out. So electrician shears or Kevlar shears are definitely a requirement. From there, we're going to go into show you how the actual termination actually works. In the cable itself, what is going on the left side of the page that everybody should be able to see, I hope, is a construction of a standard fiber. We'll use multi-mode as an example. So when we see 50-125, what they're referring to is the core size being 50 microns in diameter, and 125 is the glass cladding size, and these are industry standards. So if you see 50-125, you know it's a multi-mode cable. If you see 9-125, it's going to be a single mode, where the single mode fiber actually has the smaller core. With traditional fiber, you have a core, and with Cleerline SSF fiber, we have the same core. So nothing's really changed. The glass cladding encapsulates the light inside the core where it travels and helps protect that core as well. We have a glass cladding, but we don't take ours to 125 microns. We take ours to 115 microns. What that does is gives our cable the ability to bend more, but as everybody kind of should understand, the smaller you make something, the more flexible it is. But with glass, that makes it a lot easier to break. So what happens on our cable is the last 10 microns, we have this proprietary polymer on the right side. And that's basically a plastic coating that covers the cladding and increases the strength of the fiber itself. So with our fiber, you can bend it. You don't have to worry about breaking it. You can pull on it, and it increases the strength about 200 times that of any competitive fiber that's out there. So being fragile is not nearly what it was with traditional fiber that's out there. After the polymer, we have a 250 micron, what we call soft peel acrylite. And that is a color coding, so if you're working with multiple strands of fiber, you know which one you're working with. Traditional fiber has that same acrylite, but they also put a buffer on the outside of it, and this is the 900 micron buffer. And the buffer is a protectant to help, because the traditional fiber is a lot more fragile, and you need something there to not let it break, not help it break. So from there, we're going to actually show you a quick little video, so I'll be quiet for a few minutes, and this is the actual full process of doing an actual termination.
In this video, we will demonstrate how to terminate Cleerline SSF LC type connectors with SSF 2 or 3 millimeter jacketed fiber. Cleerline SSF pre-polished field installable connectors are fast and easy to terminate, requiring no special tooling, and are compatible with SSF fibers as well as standard fiber optic cables. Here are the tools that you'll need for this project. A fiber optic cleaver adjusted for SSF fibers, fiber optic strippers, fiber optic cutting shears, and a fiber optic VFL with 2.5 and 1.25 millimeter adapter. Step 1. Unscrew the connector boot and slide onto the 2 or 3 millimeter cable jacket. If terminating 2 millimeter cable, slide the included yellow 2 millimeter build tube onto the 2 millimeter cable jacket. Using the 2mm opening on the strippers, remove approximately 50 mm or 2 inches of the cable jacket. Turn on the VFL verification light. Place the 2.5 to 1.25 mm adapter on the VFL. Remove the dust cap and place the connector onto the VFL. Ensure the activator slide tab is in the open position, being slid towards the rear of the connector. After that, open the hinge on the rear of the connector. Pulling the aramid yarns back, locate the SSF glass fiber. Using only fingertips or nails, gently remove the soft peel colored 250 micron coating completely from the fiber to within approximately 12 mm or a ½ inch of the cable jacket. Do not use the fiber optic strippers during this step, as they can damage the SSF fiber's polymer coating. To cleave the fiber for the SSF LC termination, hold the fiber at a slight angle downward and place the cable jacket at the 24 mm mark on the cleaver. Ensure the fiber is straight in the groove and across the two pads being placed at a 90-degree angle to the cleaver wheel. Close the cover on the cleaver and firmly push the cleave wheel forward. Insert the fiber into the rear of the connector by placing in the V-groove at a slight angle and sliding forward until a small bow is created with the fiber, and the light emitting from the connector verification window dims, being almost extinguished. Maintaining forward pressure on the fiber, slide the activator tab towards the connector tip to lock the fiber in place. Remove the connector from VFL. Install the dust cap. For 2mm cable, slide the previously installed 2mm yellow build tube forward and seat in the rear of the connector. Ensure the fiber is straight and place the aramid yarns to one side. Close the hinge. To complete the connection, slide the boot forward and thread one full turn to lock in the aramid yarns. Cut the yarns closely to the boot. Tighten the boot until secure. The connection is now complete. For more information, visit the technical resource page at clearlinefiber.com.
Okay, so everybody should see that that's really a pretty simple process to actually make the connector. We do have step-by-step videos on YouTube, which AllNet will also have on, I believe, on their channel as well. So,
after Ryan.
Yes.
There's a question that came through. It says, does your polymer help reduce the operating radius that it can be utilized in?
It does. So anytime you bend regular glass, obviously there's a minimum bend radius that you can have before you create typically what they call microfractures in the glass or in the cladding. Because of the polymer and because of the smaller cladding, our bend radius is a lot smaller with a lot longer life expectancy. So, you know, any glass, including ours, no matter what you do and bend it, creates stress on it. And what you're trying to do is prevent or extend the life expectancy of that. So for instance, our fiber without a jacket on it, you can bend the glass to 2.2 millimeters with a 31-year life expectancy. Most fiber you can't bend below about 5.5 millimeters without just breaking it. So yes, it does extend and help that.
And what is the pull strength on the cable?
Off the top of my head, I believe the short-term pull strength is 200 pounds. Long-term, or short-term is 200, long-term is 80, I believe.
Right,
and it is on all of the spec sheets as well. From there, we really, a lot of the questions become, what do I hook up fiber to? Everybody kind of goes, yeah, I know we need to do it, but what is there to hook up to it? And the conversation changes on a daily basis right now, but more and more companies are obviously jumping on board. In the audio video, that's where we're seeing the biggest growth right now, and we're seeing more and more manufacturers actually realizing that this is something that needs to be done. So HDMI, DVI, really any video signal, there's companies making different balance and solutions. Just to be clear, we're not a manufacturer of any of the electronics, so we are just the conduit in between. So anything that we show or display are really just relative items to the industry. In the networking world, they've been doing it forever, and obviously there's not a lot in networking. It's more of just connecting switches together through SFPs as displayed here. Security cameras, the higher end cameras, there are some out there that have direct fiber inputs, but most of them require just like a media converter, which is on the right side of the screen there, the little planet box. It's a simple Ethernet to fiber extender and then breaks it back out at the other side. Those are great, and I'll go through some reasons of why here in a minute. And then the newest thing that I know, Bill, you guys saw, and everybody seemed to really be pumping right now is audio video over IP. Obviously, there's some companies that have been doing it for a while. I know Just Add Power's had video over IP for quite some time. There's now starting to be companies doing uncompressed audio video over IP, real 4K stuff, and a lot of things that I believe are actually going to be on display at CEDIA here in the next couple weeks. Different companies, TechLogix, Ziggin, ZV, all have video over IP products along with Just Add Power and those. One of the things that, and I apologize that the image is a little blurry, but it's the best I could get at the time. The picture up on the 3 boxes up on the top right corner, if you've noticed, they're all the same. The difference is they have 1, 2, or 4 fiber connections on them. This is a question that we get asked all the time is, well, why do I need more than 1 strand of fiber? Or why would I ever want to pull more than 1 strand if it has all this bandwidth? And the reality is it has nothing really to do with the fiber itself as much as it does the chipset manufacturing. And I say, if everybody remembers back when HDMI first came out and balance started to hit the market in category, when they first came out, you needed 2 category cables to extend it. And then a year later, they found a way through manufacturing to do it over a single chip. Fiber is no different. It is a cost issue more than anything. In order to make all of this happen over a single fiber, they have to multiplex the signals, take all 4 basically lanes of traffic and convert them down, spit them out over one, and then reconvert at the other end. And that's an expensive chip to design and engineer. So some of the companies are actually doing things where they offer it in the same box in multiple options at a lot reduced cost. So if you looked at, and I don't know the prices of these, but I do know the sort of where they lie. If a single fiber option costs $1,000 for the set, the 4 fiber option cost about 50% of that, so $500. Pretty easy to do the math. If you're running fiber that's 30 or 40 cents a foot for a 2-strand, to run 4 strands and say it's a 200-foot run is a lot less expensive to put a couple extra fibers in and buy the less expensive boxes. So one of the things we're advocating is obviously pull more fiber and have more options as far as boxes go. In the networking world, traditionally everything requires 2 strands of fiber. They've pretty well settled on data transmission being separated out, transmit and receive. So if you're going to pull for 2 switches and things like that to hook up, make sure you always have 2. I recommend never having less than 2 strands of fiber, personally. And from there, one of the little charts that we put together is just kind of where would I run fiber in a residence, and what's the minimum, and really more of what we recommend. Anywhere you're going to have from an equipment rack to displays or projectors, we say run 2 strands of multi-mode. I would prefer that you run 4 just because of the technologies and the things that are there, but again, pretty straightforward. Network switch to network switch. Again, if you're going to hook up 2 switches, you need to have a minimum of 2 strands. If it's network room to network room, I would recommend 6 to 12 strands. Network switch to access points. This one, a lot of people argue with me. Over time, we're going to need to get more bandwidth to the access points. In a residence, it may be a ways out. I'm a little more long-term thinking. If I was pulling category cable to a access point today, I'd pull a fiber with it. As more and more stuff goes wireless, access points are pretty simple. They just divide up the amount of connected devices to them. So right now, if you have a 1 gig access point, 1 device hooked up to it, you can get a 1 gig, throughput on most of them. As we get to 10 gig or 40 gig or things down the road, you're not going to be able to get that bandwidth there without having some fiber to it. AV rack to AV rack, this is pretty simple. If you're doing, multiple AV systems throughout a house and you want to have connectivity, you really don't know exactly what's going to hook up to them. Again, minimum of 2 strands, but would pull a 6 or 12 strand to there. NVRs to cameras, same type of thing. A lot of the cameras are just a single fiber, but having extra is pretty inexpensive. And then satellite dishes, this is one that we've seen some work being done on. I don't know when, but in order to stream, real 4K content and do things, they're going to have issues with copper and coax. We have seen one of the 2 large satellite providers doing beta testing. So from the satellite LNB into their switches on actual fiber. What you'll notice is that we're recommending it be single mode, not multi-mode, and this is more because this is the electronics that they've chosen so far. My preferred method would be a couple strands of fiber and an empty conduit, or at least an empty conduit out there for future. And then service in the home. This really changes. Every service provider seems to have a different opinion of what gets pulled to a house and what gets pulled inside of a house. Most of the service being ran to your residence or to a building is going to come in as single mode, just because it's coming long haul. I would say if you're going to go to your DMARC and try to extend either the service provider stuff to the inside of the house, at a minimum, I'd have empty conduit. If you're going to pull some fiber, pull a couple strands of single mode. Pretty straightforward. Basic things. These are things I don't know if everybody knows, but just to kind of keep things pretty simple. Electricity cannot be conducted through fiber. It's a piece of glass. So some of the things that we've all ran into over the years with copper are noise. Noise is generated uncontrollably by us. Unfortunately, as great as we think we are at pulling wire and staying away from electricity, motors, pumps, and all of the things that happen in these homes really create a lot of havoc that people don't understand and don't know. Something might work today, and then tomorrow you get the phone call because it's got lines in it, or it stops working. Maybe that's because when you installed the system, the pool pump wasn't running, and now it's running today, and the generator's running at the same time. These are things that fiber just eliminates. You just don't have these issues. You can run it next to power. You can run it with power, depending on the electrical codes. Lightning is another big issue. I'm out in the Rocky Mountains, and we get a lot of lightning. I believe we do in a lot of places, but lightning wreaks havoc on electrical systems, finds the path of least resistance. So having things where devices are connected, it may get to the device through the electrical, but it's not going to transmit down the category cable back to the main equipment room and blow everything else up. Security, not really a big issue in a residence, but you can't sniff it out. You can't break through it like you can with copper. Distance is obviously one of the key factors. You really don't have distance limitations. If you get into something that's super long, you're going to convert it to single mode and go that route anyway. Bandwidth, which we covered, obviously everything is spec'd as a 10 gig pipe, but with the capacity to do 40 and even up to 100 gigs, which leads you to, not knowing what's going in the future. We're all talking about 4K right now, still trying to get it figured out. In reality, 8K is already being developed, being manufactured at this point. 8K will be filmed and distributed through the 2020 Olympics in Japan. So these are things that are not really foreign and out there anymore. They're really starting to happen right now. Okay, so some new products. Anybody that has seen our products before, one of the things that we were really proud of when we brought fiber to the market was the tooling costs have always been a major expense to getting into fiber. And when we brought this to the market about 4.5, 5 years ago now, we wanted a toolkit that was under $1,000 because we thought that was better than everything else. Most of them were $2,000 to $3,000. And we've had it, and we've been very successful with it, but we weren't really pleased, and we thought we could do better. So what we're introducing now is a new fiber toolkit that will be a $499 dealer price. So for under $500, you can actually get into the fiber business these days. You get all the required tools. You get the light tester, the shears, the fiber strippers, a cleaver, and the bag. Unlike our traditional kit that we've had in the market that was $999, had all the same tools in it, just with a better cleaver. And this cleaver still is a precision wheel cleaver, similar to the one that was in the video everybody saw. The only difference is it is not built quite as well. So what I tell people is if you drop it off a ladder or drop it or something, it's got a higher chance of breaking. You're going to get the same cleaves out of it for, what we recommend, it says 36,000 cleaves. It's a lot of fiber terminations. So we feel like this is really going to be a big hit. We begin shipping these next week, and pretty excited about that. From there, we've replaced our current toolkit that was $999 with a new professional kit at $1099. And the difference is you get a hard case, you get a few more tools, you get some traditional, like some wire snips. You also get the traditional fiber cleaning stuff. There's alcohol wipes, safety glasses, there's a radial cable stripper in there as well. If you get to traditional fiber and needed to terminate it, you do need a couple extra things, being the alcohol wipes and the safety tools that you don't get with a traditional fiber kit. We have an upgraded kit that you get the professional tool kit along with a testing kit. This is a pretty remarkable thing. Testing equipment alone is usually around $2,000. Basically, you can see it's a light source that you plug into the one end of the connector. At the other end, you plug the other connector in, and you get an actual dB loss. So you can see not just visually that light's coming through, but you can truly see where the loss is. All connectors come with a recommended loss, and now you can actually test and certify. This testing equipment has data record capability, so you can actually record it, print it, certify it, and gives you an ability to be a little different than your competitor, and give your client a really nice, relaxed feeling that they have something that has been, tested and certified. The testing equipment itself, there's two versions. The one on the left is what we call our economy, and the one on the right is the professional. They look the same and basically do the same thing. The one on the left doesn't record anything. So you can still test it, you can see what your dB loss is, but you cannot record anything. So you can't leave anything behind with the customer other than them believing you and what you've told them that it actually tested out at. Both come in the hard cases and come with the little adapters and everything that's there. A couple of new cables and constructions that we've been working on that we'll introduce and at CEDIA. We're going to have a bundled fiber with two Cat 6s. Pretty simple. easy to figure out. We'll also have a bundled 2-fiber solution with 18-2 copper cable and actually one with a 22-2 power cable. So for powering these PoE devices or some various different things, really more of a commercial application, but some of the fiber to the desktop applications and things like that. Tactical redeployable cables are really not something in the residential. This is more, again, more of a rental and staging market that we're doing. And then some new designs on armored cables. So if you're doing anything outside where you don't have conduit and you need to expose it or direct bury it, we also have some of those cables as well. That is as much pain as I will put you through. All the information is available at cleerlinefiber.com and also on our YouTube channel, Cleerline SSF.